The fundamental counting principle. We're going to find out, we're going to use fundamental counting principle to find the number of possible outcomes in a given situation. So let's look at the definition of fundamental counting principle. If you can choose one item from a group of m items and a second item from a group of n items, then the total number of two item choices is m times n. So that's the formula, that's the fundamental counting principle. So look at one example. Let's say you have a choice of two pants, two jeans, and then three t-shirts, two jeans and three t-shirts. Then altogether you can have 2 times 3 different possibility. As you can see here, the one jeans goes with the 3 different t-shirts, 3 different possibility. Another jeans goes to very same 3 different t-shirts, and that gives you another 3 different choices. So altogether 3 times 2 is 6 choices. Okay, so that's coming from fundamental principle here. 2 times 3 is 6. Okay, the number of ways in which a series of successive things can occur is found by multiplying the number of ways in which each things can occur. So that means this principle here, we have m times n. It's not only 2 different items. If you have more than 2 items, you just have to multiply the possibility from each of the items. For example, let's say 2 jeans, 3 different t-shirts, so 2 times 3, and then 2 pairs of sneaker. So there are 2 times 3 times 2. Depending on how many items you have, you just multiply all the possibility, and then you find total number of outcome. So 2 times 3 times 2 is 12. So that's the reason one jeans goes with 3 different t-shirts, and then 3 different t-shirts, and one jeans goes with 2 different, each of them it will go with 2 different sneakers. So 1 2 3 4 5 6, and same thing happens with another pair of jeans, 1 2 3 4 5 6. So altogether it's a 12. Okay, so let's look at some examples. If you can choose one item from a group of m items and second item from a group of n items, then total number of possibilities is m times n. That's the fundamental counting principle. A sales representative can take one of 2 different routes from city A to city D, and any one of 6 different routes from city D to city M. How many different routes can C take from city A to city M? So there are 3 different cities. So if you just want to use the fundamental counting principle, it's just how many different ways you can get there. Just multiply, and then you are going to get the answer. Let me just go back here. So there are, let's try to understand the question. City A, you want to go from city A to city M, and then okay, city M, there is another city D. So from the question, a sales representative can take one of the 2 different routes from city A to D. From here to here there are 2 different options. 2 different options. From D to M there are how many options? From D to M there are 6. 1 2 3 4 5 6. 6. So how many different routes can C take from city A to M? So we don't know either there is a direct route from A to M. These are the only options we have. So different means it's from the fundamental counting principle, it's a 2 times 6. So total number of possible outcomes are 12. 2 times 6 is equal to 12. Okay, a person can order a new car with a choice of 8 possible colors, So there are 8 possible colors times with or without air condition. So there are 2 possibility for the air condition times with or without automatic transmission. There are 2 possibility. With or without power windows, there are 2 possibility, and with or without CD player, there are 2 possibility. All these different options have 2 possibilities, so you just multiply all of them. So it's 8 times 2 to the power 4. I'm going to use a calculator. So it's 8 times 2 to the power 4. That's total 128 different possibility. A password contains 4 digits such as 1747. How many different passwords can form? So digit means how many digits are there. So total, if you count the digit, it start from 1, 2, 3, 4, 5, 6, 7, 8 and 9. There are 10 different digits. You are going to pick 4 of them, So in every places 1, 2, 3, 4, you can pick any of them from here. So there are 10 possibility for the first digit, 10 possibility for the second one, 10 for the third one, and 10 for the fourth one. There is no other rules we have given here. So for each digit there are 10 different options. So it's a 10 to the power 4, which is 10, 1, 2, 3, 4. So it's a 10,000 different option. Determine whether the given statement makes sense or doesn't make sense. I estimate there are approximately 10,000 ways to arrange the letters. Remember, there are 26 letters. So every single time you can pick first one as a 26, second one, 25, third one, 24, and keep going, and you just have to multiply. So this doesn't make sense. So where do you go? The statement does not make sense because according to the fundamental counting principle, the number of ways to arrange the letters is equal to this multiplication. Okay, that's all for this section.